I am delighted to introduce our next speaker. And I'm gonna read the biography of David McComas, who's gonna be talking about OpenSatKit. David McComas, welcome, first of all, to Izmir. I'm so happy to see you. By the way, for everybody's information, David and Eric were so kind to, in a way, trailblaze this workshop last year when they interacted a lot and actually discussed matters with some students in final project that now have jobs in the field. So it was a very good tradition that we established with them, and I really thank them for that time as well. So David McComas founded Open STEMware to support the development, distribution, and adoption of open source software, educational material, and low-cost hardware software platforms suitable for STEM education. David retired from the NASA Goddard Space Flight Center in 2019. His 34-year, that's 34-year NASA career includes developing and testing flight simulator software, maintaining in-orbit software, and leading software development teams. David primarily worked in-house flight projects, starting as a flight software developer for the Hubble Space Telescope, and concluding as the flight software product lead for the Global Precipitation Measurement 2014 launch. Prior to its retirement, David served as the program manager for NASA's open source core flight system. So David, a warm welcome to you. Thank you so much for this presentation that you're bringing to us. And just as last year, some of the questions kind of go in one direction, some go into another. Certainly the interaction between hardware and free open software sometimes verges on the mysterious. So we all look forward to some enlightenment today as we discuss OpenSatKit with you. So please, everybody, welcome David McComas to the workshop. David, please go ahead.
All right, thanks. Thanks, Fabrizio. And thanks for putting on this workshop, because I think this is really a great effort that you're doing. Obviously, having started Open STEMware, I'm a big proponent of open source software and hardware designs as well. As Fabrizio said, I worked 34 years, and I was actually part of the initial team for Core Flight System. And that's a flight software framework that NASA Goddard made open source in 2015. So I also, I've worked with Eric as well before I left. I wish if I would have stayed, I would have worked, continued to work on Roman, which would have been a lot of fun. It's always humbling to go after Eric in something like this, because I'm a software guy and his graphics kind of blow away anything.
Well, hey, I had to follow Feynman, for crying out loud.
Yeah, well, and what a great job you did, Eric.
Yeah, right. So, but it does go in. So I'm going to do a couple slides, and then I want to jump in. So, but it's going to be an interesting year. So OpenSatKit is, and I'll be looking off. I got a screen up on the top, so if you see me kind of gazing off into space, I am just looking at my other screen. So OpenSatKit I started a few years ago, and it's a combination of the Cosmos ground system by Ball Aerospace. It's a core flight system running on a Linux Ubuntu, and then with the 42 simulator tied in. So this is a lot of, I'm relying on three big packages to bring into one. And Eric kind of alluded, with some of the open source, that creates a lot of challenges in it itself, which is one reason I only support Ubuntu. It could run on different systems, but the one that I publish and test is on Ubuntu, because it's too hard to keep managing too many platforms. But that's kind of where things are changing this year, and I'm really excited about this year, because I'm actually breaking this down into multiple products that then can be assembled. And I'll get into some of that first, and then I'll run a demo of the current OpenSatKit. And if we have time, I'll also demonstrate one of the things I've broken off, and this goes into the STEM education. I've created a very simple Python user interface that can talk to the CFS running on something like the Raspberry Pi. And one of my goals there, last summer, I participated in an internship where we really wanted to have a simple, low-cost environment where we could just run the core flight and remotely control it. So people got a sense of the operations, and the students could quickly create an app on something like a Raspberry Pi. And eventually this could build into more sophisticated applications. And that's also part of the breaking it down into multiple systems. Is right now OpenSatKit's this monolithic blob, I like to call it, and it might have 20 in the 20s the number of flight software apps, and I want to break those out into individual apps being on the web or in GitHub, so then users can assemble their own systems. And one of the things that's new is something called electronic data sheets. That's an international standard. It's part of the CCSDS standards body, and that's an interface specification. So if we package our apps right with the command and telemetry being defined in electronic data sheets, we'll be able to automatically integrate them into a system. So that's kind of where this year's going. So
the Raspberry Pi, if I might just interject, sure. The Raspberry Pi, very exciting, because I think that could be an entry point for STEM that is very important, as a realistic first step.
Yes.
Do you have a philosophy about Raspberry Pi versus Arduino?
Not really. No, I happen to I haven't really done much with the Arduino, so I can't really, but I've done more with the Pi, and that was more just because that was what the people I got involved with, that's what they were using.
Okay, great.
But it is nice because when you're in a desktop environment, it's one of the first things. I've been also working with CubeSat teams, and one of the first things they want to do is, I got to interface with a hardware device and now plug it into a whole system and now get that commands and telemetry going. And having a desktop only system really that's good for the top down, getting your functional requirements to apps, but not the bottom up part of getting the devices in a whole system. So I'm hoping the two will be complementary.
Yeah.
So the core flight system, it's got a lot of heritage. It's flying on many missions. We started it back in like 2005 conceptually, but it suffers because it's being run and led out of NASA, but NASA's project funded. So it's very hard to get funding for something outside of a project. So it's usually the biggest purse that leads the future of CFS and the new features being added. And right now, it's a good thing in one way. Right now, it's Gateway out of the Artemis program. So actually, Johnson Space Center is having a big influence. And one of the things they're doing is making it Class A certifiable. So that's pretty exciting. But anyway, so it's still got a lot of traction, but it is I'll go into the next slide. It is a framework, and that's one of the challenges. And that was one of my motivations for actually putting OpenSatKit together, because what NASA releases is a framework, and that has a platform abstraction, so you can port it across different platforms. Then it has these application services, which basically create a runtime environment for libraries and applications. Libraries aren't running per se, but they're supporting the applications. And then NASA outputs a bundle, which only has a couple live apps with it. But the challenge then is and we've also released probably 12 open source apps, we being NASA. But now that it's very difficult to understand how to put these apps together and build a system. So that was the motivation behind OpenSatKit. As I mentioned, I'm now creating a different framework, and I'm starting to pull the pieces out, and they're all going up on GitHub this year. And I've already started. So with this electronic data sheet framework, I'm starting a new, what I'm calling an OpenSatKit runtime bundle, but it's also going to have a few more apps than the NASA bundle, because it's going to have things like file management and file transfer, things that you need with every system. So out of the box, this bundle it can run on the desktop, it can run on the Raspberry Pi, and it can provide all the basic functionality of commands and telemetry. Plus it'll have this framework where the other apps that are going to be published out of OpenSatKit will have the electronic datasheet interface. So this is just more pictorial. So there's going to be the bundle now is, I have a GitHub. Like I said, I could demo that at the end where I can I'll automatically create a hello world app with a tool, and it'll just plug into the ground system with commands.
That'd be great, please. Yes, that'd be great. Thank you.
Okay, so hopefully we'll get to that. I want to get to the first OpenSatKit one because I show the 42 hooked into the runtime. And this is kind of the roadmap, and this doesn't, like I say, I've written a simple beta version of using a PySimple GUI toolkit, which is an interesting relatively new project, about 3 years old, where somebody has made a superset of the many Python ports of graphics. But that just provides a nice portable command and telemetry system. And then there's a CFSat, which I'm calling it, which is the education apps, and that's the one I can do the beta version demo later today. And then there's also going to be a simulation bundle, and right now that's in its current form. Which changed also, and you'll learn about later today, is the Ball Aerospace. They've made a big jump from the Cosmos. I'm using an older version of Cosmos. It's still supported, but they've made a whole containerized Cosmos 5.0, which I have not migrated to yet. And you'll learn about that as well.
That's when Ryan will talk about that.
Exactly.
Right? Yeah. Okay.
So this all ties together. So what I'll show you is the 4.0. Just looking for some resources actually that get some support with the Cosmos, because my plate's getting a little full. So, so real quickly, I don't want to go like, as I mentioned, I want to start putting the apps in the each with a separate repo, with bundles that can easily be assembled for different purposes. And I think I'm going to just kind of glance. Oh, one question, Fabrizio, can these slides be made available somewhere? Because I'd like to.
Sure.
Okay.
Yeah, we have ways to make that happen. We can discuss. Yeah, sure. Thank you so much.
My intention was not to go through them all, but have them as a reference so they could.
Yeah. We'll make it happen. We can discuss it. Yeah. How big is the whole PDF?
Oh, it's not. I mean, it might be 40 slides, but it's just.
Yeah, that's fine.
Yeah, it's not big.
No problem. Thank you.
I'm going to jump to this. So this is the website for the current OpenSatKit. And these other components are actually being in the same, Git repo, OpenSatKit. There's I don't have the URL here, but there is a new OpenSatKit-apps website where I'm starting to put the individual apps as I package them. And then the OpenSatKit CFSat is where I've put a beta release of this application toolkit. I'm sorry, I don't think I even mentioned that. Sorry to give all the acronyms, but so it's a core flight system application toolkit. And the idea is it's the basic, very simple runtime system for creating and working with just at the app level. And the other thing to note about the current OpenSatKit, I have this idea of a SimSat, or you could fill in sim, either a simple sat or simulation sat. And it's not fully documented, but the idea is I want to have a reference mission, and that's going to include, I mean, it does include 42, but it includes a simple architecture and some just mission requirements, and show how those become apps and become a reference mission, or get a reference implementation of a reference mission. So that's in works of being documented. But there is a quick start guide there, but it's, like I said, it's not 100% complete. But so I mentioned, here's the current one. They're being refactored and in the separate apps, so then the separate apps can be recombined into more user-specific purposes. So this is kind of the picture, I think, as Eric was talking, and there were some good questions about when you want to connect to a remote system. So in Eric's world, I'm calling his file the console. And basically it's a closed loop system. So he's got the models, the ephemeris, and the environment. And those measured states are going to go to some device models, which from a flight software algorithms point of view, we call that telemetry a lot of times. It's basically reading this from the sense data.
David, let me ask you, because we also have high school seniors in the audience. Maybe can you define telemetry, what it means to you, and you can define commands just to keep everybody following you. Thank you.
Thank you. Thank you. Yes, that is confusing. So telemetry really is just a remote data from a remote source. That's the way I think of it. So we speak of telemetry as the data from the spacecraft coming to the ground system. And then commands are from the ground system up to the spacecraft. And that terminology kind of carries forward on the spacecraft itself, even though you might just say I'm reading sensor data. If I want the sun position, the terminology, because we might send a sun position in data to the ground, we sometimes call it telemetry from a device, which can be confusing. And sure. And device, I mean, that was a generic term. So a sensor could be a gyro that's measuring your rotational rates, or it could be a sun sensor. It could be a magnetometer measuring the magnetic field. So, and then an actuator is a device that's going to, import force or torques on the system. So,
and just to keep everybody involved, if we have a robot in the parking lot, this terminology could still apply? Yeah,
as far as, it would certainly apply. And that's the wonderful thing about like CFS is people have put it on drones. They've put it in, like I say, pies that might be controlling something. I don't know about robots specifically, but I wouldn't be surprised. It's really just a generic.
So yeah, I mean,
system.
Our university once launched a probe attached to a balloon. So, but there wasn't anything to actuate in that. It was more telemetry, I guess you would call it at that point, right? If your data coming down from the probe, like it was a high altitude balloon, basically.
And we've actually had, I know there's a group in Japan that's been working with getting the robotic operating system, and they've bridged it to the core flight system. So they've been doing, and they've been publishing all their work. I think they're making it all open source as well. So what in the OpenSatKit, so here's the one picture of the closed loop 42 with the great graphics. I'm going to replace those graphics with boring screens. So now that flight software box is gone, and the algorithms, I've put the algorithms in an app. So the circle represents an application in core flight, and the box I use for a library. And so the algorithms are in one app. And as Eric mentioned, you can do a socket interface. So I made a second app that it takes care of all the I/O, the input and the output from 42. A big component architecture of the core flight is this publish subscribe message bus. And the nice thing about the message bus is it's the same form, a command that comes up from the ground using this standard from this international standards body. It's the same packet that gets routed on a bus to an application. So it's a very convenient way to use the packets that come from a ground system, which is now, this is the Cosmos. And so a command would come from the Cosmos, go to this command ingest application, publish it on the bus. And let's say you wanted to change your control mode or set a control gain, it would go to this application and change your control gain. So that's the path. And then similarly, telemetry or status from the spacecraft would be published by the different applications, and telemetry output would collect it from the message bus and send it to the ground system, where then it could be displayed on screens. It actually goes to like the equivalent of, I'll say, a database, but it's not really installed in Cosmos, where we typically a lot of times call it a current value table. So there'll be the latest value from telemetry somewhere in memory that can then be acted on by a script, for example. And these are the two main ways you interact with the system. You can do screens. Of course, that's not a repeatable script that you can run as in a test. Or Cosmos has something called Script Runner, where you can write tests or write any script, and that's what I'll demo as well. And those Cosmos is all written in Ruby, but luckily you don't have to, at the script level, you don't really have to know the real deep Ruby. I mean, you can keep it pretty simple.
So just to keep count, today we have spoken about C, Python, Julia, and Ruby.
Right.
And I would like to know if you guys are conversant in all of them equally, because you are software developers, right? So, because my students, I get this email every semester. What language should I learn next semester?
Yeah, so I only try to pick up a new language every 20 years or so. So
yeah.
In the 90s, I learned C, and because I figured it'll be around for a while. And recently I started picking up Python, but I like I said, I think I'm liking Julia better, and I think it's got, for at least me, I think I'll be looking to get good at that and carry it, for the next 20 years.
Okay, and David, your answer to that, if a student calls you, what would you say to that?
Yeah, that's a tough one. Yeah, I mean, this is all the core flights in C, so that's another.
Okay,
C.
so
some people have written C++, but that comes with its own challenges in an embedded system. So, and
I have a question. I'm sorry if I'm just doing it the round table way so that the students kind of understand. We have a little bit of a more informal conversation. And then I'll shut up. But my question is, Eric earlier spoke about Python spitting out C code. Is it doable to take one of these high-level languages? Because, for instance, Mathematica can produce C code. I think the Fortran, modern Fortran, can produce C code. So is it a doable strategy to learn one of these high-level languages and not all the others, and let them produce the code that you don't know how to produce yourself? Or do you need to be conversant in 5 languages at this point?
I think it's a mixed bag. We actually have something called the Simulink interface layer that can take MATLAB Simulink blocks and convert them into an app that runs on the CFS. But that puts some constraints in your Simulink modeling. There are some libraries you got to include there when you're doing your modeling. But so that's a translation situation. But there's times now I don't think so. I think one of the things that's coming, and it's actually because of this electronic data sheets. I know this is kind of a lot of plumbing, but it's actually, when the tool chain runs, it actually produces Python bindings. So we can now fly, it depends on the resources, but it creates bindings for another language called Lua and Python. And so in theory, maybe if we keep kind of like your operating system is, most of them are written in C. If we kept all the infrastructure apps, they could all be written in C, but now if we could get a scripting language on board, it would alleviate that in detailed knowledge. And I'm hoping that's where we can go. So that's
I should come clean about something.
It's confession time.
The Python scripts that auto generate that C code, C code is a text file. I had to write the Python code that would take another text file and interpret it and write C code based on that. So there's no magic translation from Python to C involved. That's all me taking something very targeted that I wanted and turning it into something very targeted.
I see. Well,
and actually, that's a good segue. So that the example I said, I have a Hello World app that's automatically generated. I took the exact same approach. It's basically, I wrote this little template of the C that I wanted generated, where if people name the app, it'll fill in all the right spots. And
I see. Well, and I really appreciate your honesty, because I think that sometimes the students become discouraged at now. I think that the count right now is 6 languages that you guys have mentioned. So and they say, if this is what then I'm never gonna do it, and so the question is, well, how can you make this in 4 years of a bachelor's degree be a realistic proposition, or are there, I'm not asking for shortcuts, but I'm asking for a strategy, and so I appreciate your honesty on that, and I'll let you go now, David. Thank you, please.
well, and actually related to that, not to delay myself, but it's an important question, because I wrote OpenSatKit to help with the problem of assembling a core flight system, which had its own challenges, but now OpenSatKit created new challenges. So
yeah, I see.
I even have a slide poking fun at myself where, you download it, you install it, and the screen comes up, and like, now what do I do? It's just this, it's just this big thing sitting there. And I've shifted the complexity problem, and I want to make sure I'm solving it as well.
Yeah. Thank you.
Sure. Because even, I won't even call it a language, but you got to define these screens. And in Cosmos, it's a text file that's customized to how you define a screen. Not hard, but somebody's got to learn it. You got to actually do it.
Yeah.
So it's yet another thing to learn.
And when you say educationally, I've heard you, you're a STEM educator. Is your target audience university level, high school level? Where are you placing your products?
I'm finding that right now as I exist in my semi-retirement. I right now I've been helping universities more with CubeSats, and the high school. I actually haven't done high school's mostly been demonstrations in the classroom.
I see. Thank you.
So
great.
I should run off camera and grab, if I have 5 seconds at the end. A friend of mine, Alan Cudmore, made a nice 3D printed, we call it PySat, but it's kind of a nice visual.
We can wait for you. We can wait for you anytime you want. No problem.
Okay. Well, I'll wait till I need a glass of water. But I want to get to this demo too before we run.
Yeah, I know. It's too exciting. I've been waiting for a year. So thank you. Go ahead.
So what I'm going to do, there's a controller I took out of Eric's code and I put it in an app, I just made some limits on the attitude error and said, okay, when it's in this limits for 3 or 4 control cycles, we'll call it, it's ready to take science. And the reason I made that flag was just so there's something demonstratable, because that's more getting you in an operational mindset. And then the script I'm going to run just waits until that take science data flag is true. Then it's going to turn on a simulated instrument. And this instrument just pretends that it's collecting data and writing it to a file. Nothing fancy. It's all just kind of pieces to show the system running. And as you'll see, because it's like real life, I actually changed the threshold this morning, something you should never do before a demo. But it actually bounced in and out a little bit because I changed the y-axis, was taking a while to convert, so I pulled it in a little bit, but it actually now, even with a hysteresis of like 3 cycles, it kind of comes in and out, and then it becomes true for a while. But anyways, it's all for demo to get you in the frame of mind. And I think I verbally said that. So let's go. So this is an Ubuntu desktop. I'm running in a virtual machine. I've opened a terminal window, and this is the OpenSatKit. And it's basically just got 3 top-level directories: Cosmos, 42, and CFS. Very clean architecture that way. So I'm in the Cosmos, and the way you start Cosmos is you say Ruby launcher. So Cosmos is it's really a toolbox in a sense, and it's all customizable. That's the beauty of being open source. So even this menu that comes up, these are a whole bunch of Cosmos tools. They have this command and telemetry server. A table is the idea of having a bunch of binary data together that you can treat as a unit when you and we put them in files and send them to the spacecraft. I'm not going to go through all these, but the bottom line is I could add my own tool. And basically OpenSatKit is going to be running other Cosmos tools automatically, so you don't have to worry about clicking individual things. So I'm going to start it. And what it's done right now is it started the Cosmos command and telemetry server. So that's just a tool that's, if you remember the last, excuse me, I'll bring up my, whoops. I bring up this picture. So the command and telemetry server is just this, think of it as this interface here. It's not shown here, but it's just going to manage these two paths. And then this telemetry viewer tool is the one that actually manages all the screens. So I can hide these. They don't need to be shown, but they need to be running. And I can even hide this launcher now. And I can hide this screen because it does create a lot of screens. So OpenSatKit right now has 4 different targets. The word target's kind of overloaded, but I mean a CFS target, excuse me.
And David, just to orient ourselves, this is from the Oracle VM that we used last year to install OpenStAck Kit. Is it or is it a pure Linux environment right now?
No, this is a VM, and it's similar to the Oracle, right? I'm actually using VMware, but
VMware. Okay.
Either one, VirtualBox works. It's just it's all free. Well, VMware is not. I bought it for some personal development reasons, but
and what Ubuntu are you using? What distribution are you using?
This one is 20, 20.04. 8. Well, that's actually an interesting. I don't want, again, Ryan can talk about this more. So Cosmos 4 uses Ruby Qt for its graphics, and that's no longer supported. And so that's one reason I think he can answer the questions of going this whole containerized architecture. So this does have a limited life, is another reason I'm breaking things up.
I see.
I don't know. That's a question I'd love to ask Ryan this afternoon. I don't know how long Cosmos 4 is going to be supported, but I had to run on Ubuntu 20 of luckily another open source supporter found a library that would let me run on Ubuntu 20, because I don't think Cosmos 4 runs on Ubuntu 20.
Because last year, I thought that last year we were talking about having to stay on 18. Right.
And since then, I found this student out in Ed Friesma kindly did some homework for me and found a library that's being supported that let it run.
I see. Okay, thank you.
That's the whole beauty of open source, is this collaboration.
Yeah, no kidding. Yeah.
So these different tabs run different CFS, basically different groups of apps. They're not mutually exclusive. But the one we're concerned with is the mission flight software. And as you can see, this top changed where I can start just the CFS, start it with 42. I'm not going to get through all these buttons, but the main thing, this is why I say you stare at it and just get lost, because it is a lot from a screen point of view. But what I've done is broken the applications from the mission into groups. So this picture's with each of those buttons. So we don't need to go through all these groups, but one button, there's a screen for each group. And this group is the attitude determination control. And there, if you can see it, is the I-42 and the F-42 apps. And then I made the screen that I'll show. This is what we can run things from. This is, and I can now hide this one. So this is the main screen. This has some status from the I-42 app and the F-42 app. Then there's the attitude errors, the rate errors, and torque commands. And I just, this is not everything, just chose a couple things. And Cosmos also has a plotting tool. So I just made some convenience things here. So we can watch the rate or the attitude errors come in they'll get plotted here. And as I mentioned, this flag will eventually go to the take science when the limits. So we can go ahead and run this. And then the second demo I'm going to do is running this ops demo, which is going to run the screen launch, the script runner. So if I say start, so what this just did is this is core flight system. And this is I call it the SimSat. So we run in privileged mode just because it needs some queuing resources. So what's running now without getting the core flight, that those 3 layers architecture just got started and it loaded a whole bunch of apps. So now we literally have the core flight system, which would run normally on an embedded target, running in Linux process. So it's a separate process running all these different apps that were shown in that graphics. So we don't really need and these print statements are in embedded world, you wouldn't see these. What we do sometimes in the lab, we would connect up a terminal monitor so you would actually see these. That's why it says that EVS is event service port 1. So this is like it's going out a port to a monitor. That's why we can see those. Excuse me. So this next box is asking whether to run 42 with the graphics. And I'm going to say no, because it really does with Cosmos and CFS and the graphics. And also this will get us more in the operational world. So when I say no, it's actually going to start the 42 simulator. So it's running, it's listening on port, and now we can see things come alive. So what's happening here is, so this is that closed loop in that other picture. So now it's the flight software F42 that's actually running. And these are kind of like debug statements in a sense. So these are the 42 cycles. Here are sensor packets and the actuator packets. And this is how many times the execution or this controller is executed. And as we can see, the take science is not within limits. It's, well, now it is, and it's probably going to go out of limits again. So, because I set the y-axis to 0007, and actually it goes out for a while and then it converges back in. So now we saw it go false. So this is more, and I wish I would have seen the student's presentation with the end-to-end sim, but if you ever want to get to a project of, you know, doing a more operational type scenario, this is a screen where, of course, the ground can have graphics going as well, but this is kind of your view of the world when you're looking at it from just data coming from the remote system and being displayed on a screen.
They will get in touch, I'm sure.
Okay, good. I hope this, so now the take science is back, and well, I'll show one quick, I know I'm gonna run out of, so here's something where you might say, oh, I wanna look at the controller gain. So this brought up a screen that's empty, but I can get the current values. So that sent a command to the spacecraft and it gave me all the gains. And now if you let a software guy put in the gains, he'll do something like this. You know, let's just do that for a second. And then I'll say, load the screen values. And now we're going to see our controller not behave well because you let a software guy do the control gains. Actually, oh, sometimes it's done.
Not bad.
Sometimes it gets the focus wrong, but now we'll start seeing not doing well. So anyway, it's just to show you that you can interact and tune the you know, the behavior, and then basically it's the design. That's one of the flight software designer's job, is to take, in a sense, you know, Eric's more concerned with writing algorithms that perform the function that he wants them to perform. and the flight software, it's all the other glue that you got to do, and that makes it work. So we can just, I have a button here that says restore defaults. So it'll put it back to where it was. And that's where we get more of the operational sense too. Part of our job is, you know, to do things like to take science, and there's another application that's going to be monitoring all these errors and the rate errors, and if something goes wrong.
And I want to ask you, in terms, you're doing here attitude control, right? You were saying, yeah. So, for instance, for the students who are doing solar sails here, the big deal is to align the solar sail away from the sun or towards the sun or something like that. Can you define, could you write a piece of software in which attitude is with respect to the sun, for instance?
Yes. Yep. And that's exactly, yes. The short answer is yes.
Okay.
And from the challenge in this environment is making sure all the data that's in Eric's world available through the interface app. And what I basically did was take Eric's code generation and did he has this big structure. I call it cheating in a way, because I just took the whole thing and put it over. So it made porting the algorithm easier.
But are you injecting noise into the system here?
I am not. Right now, all I did was from a simulation point of view, I just created my own. I took Eric's Aura spacecraft and used that as the default when somebody starts 42 from this environment. And that's somewhere I did want to have more closed loop and tie it in. I mean, he has that scripted time-based system. It would be it would be very neat to tie it in together.
Yeah.
So at a predefined time, or even manually, I could add noise. I have no simulator interface right now. I just set a long sim time so it wouldn't time out.
I see.
So we can stop.
And the Arduino, is it a short leap from here?
It's interesting from a closed loop point of view. It's a bigger leap, but it may not be, terribly far. It's an interesting project. I would be, that would be. I'm hoping after I get this very simple environment set up. See, part of the problem, I have different users. Some people just want the core flight with the apps, but now with this simple Python, I might be able to, they may not want the full-blown Cosmos. But what I'm thinking of is you could pull in 42, pull in the simple Python and close the loop maybe, or maybe the full Cosmos. I haven't played with the containerized Cosmos, so that might make it very suitable for that too, kind of combining the three pieces. And
in there, when you were hitting the button, take science, how was science defined? I mean, when you say take science, what is it, a sensor or?
I just based it on saying if the attitude errors in all three axes were below some limit for some or control cycles, that just meant, and it's kind of based on, we've done this on missions where you want the stability before you actually turn on the instruments or say it's quality. And one CubeSat I'm helping right now, they just want it based on the latitude. And they want to just turn science on and off as they go over the poles. And
I see.
There are a lot of operational things like that.
Okay.
And one of the other things that helps that I don't have shown here, we'll have a fault detection and correction running in the background. And if you think you're taking, you want to make sure, keep checking that you're within the performance that you say you're going to be in, unless something's gone wrong. So the only other thing, do I have time for quick?
Yes, you do, and then I'll ask if there are any questions from the student groups.
Yeah, so this I wanted to, so this would be more, if you want a repeatable, this is analogous, maybe semi-analogous to Eric's, the startup script he had. So this is a demo script, and this is Cosmos script runner. And so, and as you can see, it's not real heavy programming. You just got to, you do have to know what's available to you. But I mean, here is displaying, it's going to display a screen. This little logic here is going to restart the core flight and then start 42. And here's a line that's just going to say, wait for the control packet, take science to equal true. Once it's true, it's going to say, let's power on the instrument. So, and that's it. That's the whole demo. And then basically I wait forever until somebody hits go, and then I power off the instrument. So I'll go ahead and start this. This is kind of, so if you wanted a repeatable test or a demonstration, this is kind of, so now it's going through, I had to stop the CFS, so now it's starting the CFS again. And I brought up one new window. This is my science instrument window. So the science instrument is currently off. And now I'm being asked to start 42 again. So again, I'm not using graphics to keep it. But we'll see that it's waiting for the science to be true, which it's false right now.
Mm-hmm.
And then when it becomes true, we should be able to see these work together. This is one reason I changed the limit today, because it was taking forever to get true before I had.
Yeah.
Which is actually always a interesting thing about limits, is whether it's good enough or what is driving how.
Yeah, obviously. Yeah.
For fault detection, especially. You want to make sure. So now it went to true. So this just went to simulation of power on. Now we see the instrument turn on. And I made a fake kind of a warm up time for the instrument. So it can't start taking science yet. It's got this emit cycle, which is waiting for, it's hard to tell with that screen, but it's waiting for the instrument to say instrument power state equals ready. And when it's ready, it's going to say start science.
But now the science is turned false in the time that it took for that to become init.
Yeah, I know. That's a problem when I tweak this limit. Yes, but I didn't want to wait. My demo was taking too long. So I said, okay, I'll let it. So now we are taking science.
Okay, got it.
So I'm a little confused by the file open, but anyway, it's now writing to this file. And I have other things where you could set a fault on the instrument, and those are for other demonstrations. But this is the basic idea of trying to run a closed loop simulation using all the tools. And then, if you want to shut down, but script runner is really the way you'd want to go if you're trying to run a repeatable scenario. So basically this just turned off the instrument, and we'll just clean up the windows.
And you have coupled this to the Raspberry Pi?
Yes, but not a closed loop with 42. So the Raspberry Pi was literally just just some, I'll call command and data handling features. Okay,
I see. No, I thought that you could unplug an instrument in this control loop and put a Raspberry Pi in there, pretending.
Yes, that's a goal I'd love to get to.
Okay.
And that was the motivator for this internship last year, was they had done this Pi kit for multiple times, and they wanted to add they had no software other than the students writing in the Python that came with the Pi, but it didn't really give them a sense of that Pi being a spacecraft, because they were just writing all their Python on it. Nice. So we were looking at ways to make it more realistic. Yeah,
that's what you want. Okay, sounds good, David. So let me, I mean, first of all, is this a natural stopping point?
This is a great stopping point. I didn't get to the other toolkit, but I can do that another day or another hour.
The only thing I want to do is to ask the students if they have questions, and if there aren't any, you can continue for another 2 or 3 minutes. And so let's see what happens. So from the student audience or anyone in the audience, do we have any questions for Mr. McComas? I guess that now nobody's going to ask questions because they want to see more, you see.
Oh, well, I don't know if I can show it that fast, but maybe what I'll do is just, let me think here. Yeah, I wasn't quite. Let's see. Let's see where. I was going to bring up the other tool real quick, but now I'm going to rush.
Oh, don't worry. It's okay.
Well, I can show, I won't go through the thing, but I can show this tool is online. I'm just trying to remember. I have a. I can't explain myself. I'll just go.
Yeah. It's always the masters make it look so easy.
Oh, that's. Oops. That's what I did for Rush. So. Oh, oops. I got to shut everything down. They're conflicting with each other.
Yeah.
That's what you get when you rush. Let me
Yeah.
stop. Let's see if that, well, I might be able to stop this real quick. And let's see if we can. All right, I'm gonna.
Yeah.
I might not be able to rush that fast. Okay, yeah.
That's okay.
Yeah.
No worries. We'll hopefully communicate again. And now that we understand a little better where you're going, and I think that for both you and Eric, my wish would be a 2,000-page manual that takes you from zero to now. You know, that's what we would like to do. Because as a teacher, you know, we like textbooks, so that would be a great way. Unfortunately, your stuff is always a little, especially yours, David, is a moving target due to the evolution of various environments.
And one thing I'm trying to help, so I won't, here's a new tool that's a lightweight Python. And what I'm trying to do here is, so create hello, I'm embedding the tutorials in the product. So if I say create hello world app, I can create a lesson, start a lesson, and now you can have all the screens.
Wow.
And say, and you can do these with the tool as you have this, you know, you need a little screen space, but this is my new approach to help solve some of that. I'm hoping. So literally this gives you the instructions to create your hello world app.
That's fantastic.
So anyway, that's, so I guess I did demo a little bit.
Yeah. No,
so under there, there's create app, and we can create a new one and all that. So I won't go through it, but it's all self-documenting. So
well, we will reach out, and if you need guinea pigs,
all right,
we'll provide them. Yes. All right, David, that was great. I'm so impressed, really, and it's always I'll tell you that you and Eric have this amazing synergy. By the way, the students always ask me, you know, can you guys ever stop, because the energy seems irresistible. So, and I really am very excited to see this happening, and also it's very important for the students to see how a product such as 42 becomes part of another product, because that, you know, that's the dynamics of free open source. I think is very important there.
Yes, I'm standing on the shoulders of giants. Three of them. The Cosmos.
Well, that's very humble coming from you, because really you are one of those giants as well. So, all right. Well, thank you. We will thank Mr. McCommas right now, thanking him for coming to Izmir digitally. And I want to say to you, David, that you will be welcome to join us in person, face to face, if in the future this goes somewhere.
Eric's delightment. Yes, I would be delighted.
we have good food.
Yeah, and beautiful scenery. Everything.
Oh yeah. There is no end to that. So I assure you that you will be well treated. So, all right. So we'll stop here. Thank you so much, and very impressive. And I will just stop here. And what I will say is we'll give ourselves our customary 5-minute intermission. We can stop the recording now, and